We're the new kids on the block, and somebody has to be the first.
People think of algae as pond scum, but algae could potentially be part of the solution to our energy crisis.
The world is addicted to oil. I think we're really at that breaking point right now.
My grandpa came here in 1942, and I'm the fourth generation. When I came back from playing ball, I didn't know exactly what I wanted to do. I kind of came back here to figure it out. When you get that dirt on your fingernails, it's hard to get out. And it's true, Right now, it's farmed with my dad and uncle. We farm about 2,800 acres.
Anytime you're in an industry like we are, you're always looking for another way to make more money. To have your corn stalks turn into a money market for you, that's always good.
About 6 years ago, the local ethanol plant was looking for farms to run this whole project of corn stover and harvesting it and making it into cellulosic ethanol. And so we were one of the lucky ones that had a chance to try out.
As one looks at the supply chain for bringing biofuels to fruition, you have at the beginning the growing of the crops, and then the harvesting, the pre-processing, and getting them ready to go to a biorefinery, such as Poet. There is an enormous amount of logistics in gathering in the amount of biomass that one needs to do a monthly consumption of a large biorefinery, where you have 20 million gallons per year capacity at that plant when it's fully on stream.
So inside here are the grinders that grind those bales that you've seen earlier, and they grind it into smaller pieces, and then that conveyor brings the ground biomass up to what we call the pre-treatment process. And that pre-treatment process, through temperature, time, water, and pH, starts to break down the biomass. These tanks you see here are called saccharification tanks. We take the biomass that's been ground and pre-treated, enzymes added at that point. It's where the sugars start to break down to a point where the yeast can then start converting it to ethanol.
The challenge has always been, how do we crack cellulose so that we can get access to that sugar and make it into energy? And through DOE, we got a pretty significant grant to bring this technology to commercial scale. Once these first plants get going, we really think that cellulosic ethanol is something that's going to be able to expand to really all parts of the country and really all parts of the world. The opportunity is there, the market is there. We need to keep this momentum going.
We have a massive amount of stover on our farms. It's going to be here whether we're producing cellulosic ethanol or not. We've been harvesting bio-stover in a renewable and a sustainable way. Now we have a second cash crop. It's more jobs for the young farmers that are coming back to the farm. And so I think there's going to be even more people getting on board. And that's what has to happen with this whole process.
I grew up in Colorado Springs. I've lived here my whole life. Most of my friends, they were into sports, which I wasn't very good at. But in high school, I was able to join the Science Olympiad team and the Science Bowl team, and I got really, really involved in my research. I was basically looking for an idea that had to do with chemistry or biology. And I also wanted an idea that addressed a major global issue. I actually heard about people who were making biodiesel that can go straight into a diesel engine, and they were doing that all in their garage. And that idea fascinated me. A big problem with biofuels is, where are we actually getting this oil from? That's why I started looking at algae as an alternative oil source. This is actually, we're under my bed right now, and this setup, this lab, was something that I made like the summer after my sophomore year of high school with some supplies that I'd borrowed from a local school. And I would spend all night doing some experiments on algae with a flashlight and a book if my parents would let me, which sometimes they caught me. There's a lot of really interesting new research into how we can possibly increase algae's oil production and make it a more feasible source of these oils to be converted into fuel. And that's really where my interest was. I wanted to see if there was a way that I could impact the metabolism of the algae to try and make them overproduce oil.
Wow, there she is! How you doing? Welcome back. Is it good to see you? She came to us as a STEM student. There was very little ramp up or spin up time for Sarah. She had done her reading. School of Mines, we're collaborating.
Here I worked with some stress experiments. The idea being that if you can stress these cells out, they can actually start to produce more oil as this sort of response to this environmental stimulus. And so I was looking at that effect so that I could compare it with some of the research that I was doing in the lab setup I have at home.
First place winner of the 2013 Intel Science Talent Search, Sarah Bowles.
My senior year of high school, I won the top award at the Intel Science Talent Search for my work using artificial selection to improve the oil content of algae for applications in biofuels.
She had a 200% increase in productivity for algae species by doing selection through the different species. It's very exciting to see new scientists and engineers who care passionately about the area of bioenergy. And I'm sure there are hundreds, thousands of other Sarah Bowles out there who are on the cusp of finding out how they can have a profound impact in the field of bioenergy now and in the future.
I had one young man that told me when he got done with his research work here at the Academy, he said, wow, I am actually working with this stuff that one day I might be placing in my jet that I'll be flying. That really captured the whole idea and the essence of what we're trying to do to promote this intellectual curiosity. Get these young men and women interested very early on in science so that they have these opportunities to go on to college and learn the types of things that they need to advance this technology.
I just finished my freshman year at MIT. I really love it there. I think it's a really great fit, and I'm doing some really cool research there. I really can't think of a better fate than never leaving school.
My co-founder and I had been talking about how we could use biotechnology to improve the planet and the environment since we were freshmen in college in the late 80s. After a lot of years and a few degrees and some other fits and starts, we came out here in the early 2000s to build a disruptive company.
Which is good, because you know that I've been doing this.
There were quite a few bumps along the way, and our very original technology, the way we were trying to grow algae to make oil, didn't really work well.
Making a project commercially viable is a risky proposition. So we're here as a resource to industry. Companies come to us with a test tube with an idea, and we really help them move on a tech-to-market trajectory. Department of Energy invested over $20 million in this facility. It's flexible, it's state-of-the-art. This is something that not every company can invest in, early on especially.
It's important for public-private partnerships to drive down the costs. And then once it's competitive, once it's sustainable, so it's set up for long term, it's process control, it's robust, then it can have a profound impact. Then it can have consumer confidence.
What we realized is that you can have a great idea, but the science may not follow your great idea, and ultimately you need to learn from what the science tells you, and you need to try, fail, make a change, try again, probably fail, make a change. And then you start to make improvements, because finally you find something that works, and then you make a change and it gets better.
These are new technologies, and so you really have to give yourself the time, the resources to develop the technology to a point where you can integrate it, you can understand all the variables, and really reduce the risk of your project.
One of the great things about being in California and Silicon Valley is that this is a place where people follow the technology. We attract people who are looking to be out there on the edge of innovation and are willing to fail on a path to very big success. And we've, over the last more than decade now, managed to scale up the process of producing oils from microalgae to massive scale and large volumes. We We've been partnered with the U.S. Navy since 2007, 2008, delivering larger and larger quantities of fuels that meet their specifications to run their planes and their ships.
We know that we can make fuel from algae. We simply have to get algae cheap enough that we can use it to fuel our cars and our trains and our planes.
People understand that there are technologies that reduce their environmental footprint, but they don't know where they can get them.
I just like the fact that it's saving the environment. It's made here, and it's 50 cents less than what the regular gas is here, so I'm sold.
When you can drive into a gas station and fill your car up and drive around on it and tell people about it, it's probably the single best thing that can be done.
The big picture is that fossil fuels are a finite resource and climate change is real. And those two things are overwhelming drivers for the world going forward. So we have to have a sustainable solution that allows us to continue to fuel the world in a way that we don't just completely trash the environment so the planet becomes unlivable. And then we need to continue to do the research both on the biological side to make better strains and on the engineering side to make that whole process more efficient. And I think all of those things are going to come together in the next 4 or 5 years. But they'll only come together if people demand that we have low carbon fuels.
Around 2005, 2006, we realized that there was an opportunity here to introduce biofuels into the Tudor United Sports Car Championship to build a whole green racing platform. And all of the cars competing, Chevrolet, Corvette, Porsche, Ferrari, BMW, SRT, Dodge Viper, they're all competing with that cellulosic E85. When you think about the source of our biofuels, this is a domestic product. This is putting people to work in our communities. It is utilizing largely waste products that would otherwise be filling up our landfills. All of those examples are good for our economy, for our environment, for our communities, and really for the whole of the United States. And the small role that we're playing in that gives us a lot of pride.
Underneath me here, we have a large amount of biomass. We push the wastewater through that. The biomass is cleaning the wastewater and giving off this beneficial byproduct called biogas that we push into these big balloons behind me here. So about 12 or 13 hours a day, we're producing about 500 kilowatts of energy. On an annual average, we're producing about 14% of New Belgium's electrical demand with this byproduct from the wastewater treatment process.
Bioenergy is on the cusp of greatness. We're beginning to see the first plants come online, shake down, and produce significant volumes. We're seeing technologies come to fruition.
We are making our plants small, we're making them cost-effective, and we're making them produce a fuel that can be used in any car in this country. Our investors include large oil companies like ConocoPhillips and BP, General Electric, Google. They've seen the promise of this technology, taking a waste biomass, turning it into a conventional fuel that can be used in conventional vehicles, and at a scale that doesn't require the infrastructure.
So that's jobs for manufacturers who are harvesting up that biomass. That's jobs for scientists and engineers. And it's homegrown jobs, and it's new jobs, and it's maintaining the US's competitive advantage, driving ultimately to billions of gallons of biofuel.